Hi everyone, welcome to Winpoint online classes. In this session, we are going to discuss properties of magnetic field lines and some of the questions related to this chapter. The topics which we are going to cover in this session are properties of magnetic field lines, questions and answers. Let's start the discussion. Draw magnetic field lines around a bar magnet. We are going to draw magnetic field line around a bar magnet. Here, this is the magnetic field line around bar magnet. Now we know about magnetic field line. Magnetic field lines are the imaginary line. These are coming from North Pole and it is going to South Pole. It is a continuous loop, right? Next one. List the properties of magnetic lines of force. Here we are going to discuss the properties of magnetic lines of force. We know that magnetic field lines are starting from North Pole and it is ending at South Pole. Magnetic field lines are continuous loops. This is the first point. If you are considering a magnet, it is a magnet and these magnetic field lines are continuous loops. So we can see that here it is starting from North Pole and it is a continuous loop, right? This is the first point. Next point. Here we are considering the magnet again and it is starting from the North Pole. Magnetic field lines are coming from North Pole and it is ending at South Pole. That's the second point. Here you can see that it is starting from North Pole and it is ending at South Pole. That is the second property. Magnetic field lines are going from North Pole to the South Pole of the magnet. Second property. Now we can discuss the third property. Here you can see the magnet. Outside the magnet, the magnetic field lines are starting from North Pole and it is ending at South Pole. But what about inside the magnet? We already discussed, it's a loop, right? So inside the magnet, it will be starting from South Pole to North Pole. It is starting from South Pole and it is ending at North Pole. Here you can see that inside the magnet, it is starting from South Pole and it is ending at North Pole. That's the third point. Inside the magnet, magnetic field lines are starting from South Pole and ending at North Pole of the magnet. Next one. Here you can see a magnetic field line. It is a field line. It is one of the part of magnetic field line. Just imagine there are two magnetic field lines. How we can find the direction of this magnetic field line? It is curved one. It is a curved path, right? It is a curved line. If it is a curved line, we need to draw the tangent. Here we are drawing the tangent. That is the direction of magnetic field. Here this is the direction of magnetic field. Just imagine there are two magnetic fields. They are intersecting each other. Here there are two magnetic fields. They are intersecting each other. We are considering intersecting point. This is the intersecting point. At the point of intersection, there will be two tangents, right? Because there are two magnetic field line and at the intersecting point there will be two tangents. We are going to draw that two tangents. Tangent number 1 and tangent number 2, which means there are two directions for this magnetic field at the intersecting point, which is not possible. Two direction for magnetic field line at intersecting point, at same point two direction for magnetic field, it is not possible. So two magnetic field lines are not going to intersect each other. That's the next point. Two magnetic field lines never intersect each other. If they do so, there will be two directions for the magnetic field at intersecting point, which is not possible. These are the properties of magnetic field line. The properties of magnetic field line, it is very important question for your board exam. Now we can go for the next question. Why don't two magnetic lines of force intersect each other? The same question, we have discussed it now. Two magnetic field lines are not going to intersect each other. Why? Two magnetic field lines never intersect. If they do so, there will be two directions for the magnetic field at intersecting point, which is not possible. A current through a horizontal power line flows in east to west direction. What is the direction of magnetic field at a point directly below it and at a point directly above it? Here there is a conductor, it's a power line and the current is flowing from east to west. Here you can see the direction of current, it is east to west, right? We need to find direction of magnetic field. Magnetic field around a conductor, it is in circular shape, right? And we are going to apply right hand thumb rule. We are taking our right hand, we are holding the conductor. Thumb is indicating direction of current, right? Here the thumb is indicating direction of current. The encircling fingers will indicate direction of magnetic field. The magnetic field are circular in shape. So here the encircling fingers will show the direction of magnetic field. It will be the direction of magnetic field according to right hand thumb rule. Now we are looking from east direction. When we are looking from east direction, you can see that it is in clockwise, right? It is in clockwise direction. When we are observing from west, it is in anti-clockwise direction. Now we can write the answer. The current is in east-west direction. When we are looking from east, the magnetic field turns clockwise, and from west, the magnetic field turns anti-clockwise. If you like this video, please subscribe to my channel and visit our website www.winpointonlineclasses.com. Thanks for watching.